Numerical methods, iteration examples. Explain why this iteration formula converges to a solution of this equation. Now the easy way to do this is to start off by removing the n plus 1 and the n. So you've got this equation, and then if you square both sides to get rid of the square root, multiplying by x throughout to get rid of the fraction, and then take all your terms to one side. So there you go. So this iteration formula can be rearranged to go all the way back to this equation here. That's the easy way to do this. Here is another approach to the same problem. So this time I'm going to start with the actual equation rather than starting from the iteration formula. So I'm going to rearrange this to have x cubed is equal to 11 minus x. So I've taken these two terms to the right hand side, and now I'm going to divide both sides by x. So dividing every term by x and then simplifying, so that gives you x squared is equal to 11 over x minus 1, and then if I square root both sides, x is equal to 11 over x minus 1, and I'm square rooting, and then the final step would be to put the n plus 1 on the left hand side, and wherever you see x on the right hand side, put the n in like this. So this is the iteration formula. Now looking at both of these approaches, this one is clearly easier. It's not so easy to spot from this that you need to rearrange everything to make this term the subject to begin with, and then to divide by x, so that you end up with an x squared term, which is where you eventually get the square root from. In this example, we're going to show that these two iteration formulae both originate from this equation. So to begin with, if we remove the n plus 1 and the n's, and then on the left hand side here, if we multiply by x squared throughout to get rid of the fraction, and then take all the terms to one side. So there you go. We've shown that this iteration formula comes from this equation, and this iteration formula comes from the same equation.